Hello friends, welcome to engineering tutorial. Now in my previous video related to transistors or the bipolar junction transistors, we discussed about the working of NPN type transistor or NPN type BJT. So in today's video we will discuss about the working principle of PNP transistor. Okay, so here you have the circuit diagram or the connection of a PNP transistor. So here we have used the PNP BJT block instead of the symbol, so that you can actually visualize how the movement of the majority and minority charge carriers takes place. That is, the majority charge carriers are holes and the minority charge carriers, which are electrons, because it is a PNP transistor. Okay, so here is the diagram. We have PNP blocks: emitter, base, collector. Now the p-type emitter is connected to the positive end of the supply VEB, which is the emitter base voltage, and the n-type base is connected to the negative end of the base emitter voltage. Why? Because the emitter base junction of a BJT or a transistor is always forward biased. Now the collector base junction, here the p-type collector is connected to the negative end of the supply, the collector base voltage, and the n-type base is connected to the positive end. This reverse biases the collector base junction. It is because the collector base junction or the output junction of a BJT is always reverse biased. So we have the emitter base junction forward biased by the emitter base voltage, and the collector base junction reverse biased by the collector base voltage. Now, as this p-type emitter is connected to the positive end of the supply VEB or the emitter base voltage, this repels or pushes the holes, okay, which are represented by these green dots, which are the majority charge carriers, as it is a p-type block. Okay, so here we have the p-type block connected to the positive end of the emitter base supply. This repels or pushes the holes towards the base, towards the n-type base. Okay, so when these holes they move towards the base, this leads to the generation of the emitter current in the same direction. We know that the direction of movement of holes is the same as the direction of the conventional current. So the movement of the holes from the p-type emitter to the n-type base generates the emitter current in the same direction towards the BJT, towards the emitter in this direction, which is IE. Now in the n-type base, as the majority charge carriers are electrons because it is the n-type block, some amount of holes, nearly 5% of the holes which travel from the p-type emitter to the base, they recombine with the electrons. That is, electron hole recombination takes place. As a result of that, 5% of electrons are lost. Okay, this electron hole recombination leads or produces the base current in the downward direction, in this direction. Okay, away from the BJT, which is IB, the base current, which is due to the electron hole recombination. Now the value of base current is very small in terms of microampere, whereas the emitter current is in terms of milliampere. Now after recombination, the remainder of the holes, okay, the remainder of the holes, nearly 95%, okay, from the holes which travel from the emitter, which get lost. 5% are lost because of electron hole recombination. So the remainder 95% of the holes, they move from the base to the collector. This negative end of the supply, which is connected to the p-type collector, it attracts more and more holes towards it. Now this movement of holes in this direction leads or produces the collector current in the same direction, as the direction of flow of conventional current is the same as the direction of flow of holes. Now you would have noticed that in the block I have represented the holes, the movement of holes represented by these green dots. But in the outer circuit, I have used the red dots, which are electrons. Okay, the green dots are holes and the red dots are electrons. It is because holes, it is a hypothetical concept. Okay, holes never move, they are vacant sites or vacant spots which are occupied by electrons. Okay, the movement, there is no such thing as movement of holes. Only thing which moves is the electron. Here, for the sake of simplicity, I have used the movement of holes so that you can understand in a better way. It is actually the movement of electrons which causes the change in the location of these vacant electronic spots. So in the outer circuit, the electrons, they move in the opposite direction to that of the holes. It is because the direction of movement of electrons and holes are opposite to each other. Okay, now I will make a separate video on the basic concept related to movement of electrons and holes, and how holes and electrons are created in semiconductors. So for the time being, you just understand that holes, holes simply means the absence of electron. Okay, these are vacant spots which are waiting to be occupied by an electron. Okay, these holes are nothing but empty spots which are waiting to be filled by electrons. They have strong affinity or strong force of attraction for electrons, these holes. Okay, so the holes, they never move. It is actually always the electrons which move from one place to another. These movement of electrons causes these location of the vacant spots or the holes to change from one place to another, which we see as the movement of holes. Okay, so here in the PNP transistor, we can see that the emitter current is directed towards the transistor, while the collector and base currents, they are directed away from the transistor. Okay, the collector current is nearly 95% of that of the emitter current, which is more or less the same as the emitter current. The collector and emitter current are in terms of milliamperes, and the base current, which is very small, is in terms of microampere. Now, if we apply Kirchhoff's current law here, we will get that the emitter current is actually the summation of the base and collector current. So nearly the emitter current is the same as that of the collector current. Now all these things are the same as that of the NPN BJT. The only difference between NPN and PNP BJT lies in the majority and minority charge carriers. In NPN BJT, electrons are the majority charge carriers, holes are the minority charge carriers. In PNP BJT, holes are the majority charge carriers, while electrons are the minority charge carriers. Okay, but the underlying principle, the movement and the emitter and base current and collector current, they are the same. Another important thing is that in NPN BJT, IC and IB are directed towards the transistor, IE is directed away from the transistor, whereas in PNP BJT, IC and IB are directed away from the transistor and IE is directed towards the transistor. Okay, so here we have discussed the working principle of the PNP type bipolar junction transistor. Now in my next video I will discuss about the basic concept related to movement of holes and electrons and some other concepts and information related to holes and electrons so that you understand these things in a better way. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.